Hello, this is video number 2 for Professor Pastor's Materials for Industry class at Tidewater Community College by Mariella Manipol. Today I will be doing my presentation on cobalt. So this is where cobalt would be on the periodic table. As we can see, it has an atomic number of 27. The symbol is CO. The name is cobalt, and there's the electron configuration. So some properties of cobalt: it has a melting point of 2,723 degrees Fahrenheit, a boiling point of 5,301 degrees Fahrenheit, and a hardness of 5. So let's get into some of the history of cobalt. So in ancient times, cobalt compounds were unknowingly used by ancient civilizations to create blue pigments in glass and ceramics dating back thousands of years. In the 16th century, miners in Europe found mysterious ores that gave off toxic fumes when smelted, but yielded no valuable metals. They blamed kobolds, mythical underground goblins, hence the name cobalt. In 1735, Swedish chemist George Brandt isolated cobalt metal for the first time and proved it was responsible for the blue color in glass, not bismuth as previously thought. This made cobalt one of the first metals discovered in modern chemistry. In the 19th and 20th centuries, cobalt gained industrial importance in dyes, magnets, and alloys, especially during the world wars for military equipment and aircraft engines. In the 21st century, demand for cobalt surged with the rise of rechargeable batteries for smartphones, laptops, and especially electric vehicles. So I know we were all curious about what a cobalt looked like. So here's that. So metallic gray in its pure form, bluish in its compound form, cobalt is a byproduct of copper and nickel mining. The Copper Belt in Central Africa is a major source of cobalt. This is a region on the border of northern Zambia and southern Democratic Republic of Congo. Now let's dive into some of the uses of cobalt. Here we have batteries, superalloys, hard metals and tools, and catalysts. Batteries, used in smartphones, laptops, tablets, and especially electric vehicles. Cobalt improves battery stability, energy density, and longevity. And to circle back, we're talking about mainly lithium-ion batteries, which is what cobalt is mostly used for. In superalloys, they are used in jet engines, gas turbines, and other high-performance equipment. So that would be like little tiny cobalt batteries helping out with and combined with other metals in the superalloys. So cobalt also helps withstand high temperatures and corrosion. In hard metals and tools, combined with tungsten carbide to make cutting tools, drills, and wear-resistant parts. In catalyst, it is used in petroleum refining and chemical production. For example, the Fischer and Tropsch process. Some more uses: magnets, medical and radioactive uses, and pigments and coloring. In magnets, cobalt-based magnets are used in electric motors and electronics. Medical and radioactive uses: cobalt-60, a radioactive isotope, is used in radiotherapy for cancer treatment and sterilization. Lastly, we have pigments and coloring. Historically, it was used for blue pigments in glass, ceramics, and paints. So here we have some visual examples of what how and what cobalt is used in. So We have the batteries. We have a piece of china, I believe, or a vase for the pigment. Then we have a cobalt ring. Now let's get into the manufacturing process of cobalt. So the manufacturing process of cobalt is fairly involved and can be broken down into extraction, concentration, refining, and shaping into usable forms. Mining and extraction. Most cobalt comes from copper cobalt ores in the Democratic Republic of the Congo. Some comes from nickel-bearing laterite ores in Indonesia or Australia. It is a byproduct of nature. When copper or nickel is mined, cobalt occurs in smaller concentrations and is separated during processing. Ore processing and concentration. For copper cobalt ores, also known as sulfides, the ore is crushed and ground. It goes through froth flotation to concentrate cobalt minerals along with copper. For laterite ores, which are nickel-rich, they undergo high-pressure acid leaching, also known as HPAL, with sulfuric acid to dissolve cobalt and nickel. Impurities like iron and aluminum are precipitated out. Separation from copper and nickel. After leaching or flotation, the solution contains a mix of cobalt, nickel, copper, and iron. Several steps are used to isolate cobalt. Solvent extraction, specific organic solvents pull out cobalt ions. Ion exchange or precipitation, as cobalt hydroxide or carbonate can also be used. Copper and nickel are removed first, leaving cobalt-rich solution. Refining into pure cobalt. Electrolyning, which is a common method. Cobalt ions in solution are plated onto stainless steel cathodes using electricity, which produces high-purity cobalt metal sheets. Chemical reduction. Cobalt compounds like cobalt oxide or cobalt hydroxide can be reduced with hydrogen gas to produce cobalt powder. Manufacturing into usable forms. Metal, melted and cast into ingots, cathodes, or powder. So here in photo 11, we have a metal version of cobalt. Chemicals, cobalt salts like cobalt sulfate or cobalt chloride are produced, important for batteries, catalysts, and pigments, as we can see in photo 12. Lastly, we have alloys. Cobalt is alloyed with other metals or superalloys, such as jet engines or turbines in magnetic materials. As we can see, when the wind turbines in this example, and like I talked about earlier in the presentation, how there are tiny little cobalt metals found in these alloys. So the cobalt industry faces scrutiny because of environmental impacts like acid leaching and tailings, and ethical issues, child labor and artisanal mining in the Democratic Republic of the Congo. So many manufacturers are working on recycling cobalt from spent lithium-ion batteries to reduce the reliance on mining. So here are my citations for this presentation and video. I hope you guys enjoyed it, and I will see you guys in the next one.